So how does a sound wave actually travel? We'll try to demonstrate that using a Slinky. If I stretch the Slinky, you'll notice that the loops move back and forth. When a sound wave is generated, it creates a quick movement. So when the vibrations occur, it pushes the air, and that travels along the length of the Slinky. So let's tie the Slinky at each end and watch how it moves as we generate a little wave. So watch now what happens when I compress here. When I compress, the sections of the Slinky come together and then they go out. And as the wave bounces off the end, you can see that it comes together and goes out again as it passes by. Now a sound wave travels by causing the molecules to come together, which in turn cause the next ones to come together, and then as they move back, it causes a rarefaction, a separation of the molecules. And so they continue to go back and forth, and as they go back and forth, they cause the neighboring molecules to move back and forth. And so you have a series of compressions and rarefactions as the air waves carry the sound from the source to the listener. So when the tine of the tuning fork vibrates, it goes in one direction, which causes a compression of the air. As it goes back, it causes a rarefaction. And so this compression and rarefaction is sent to neighboring air molecules until eventually it hits your ear. And so you have a compression reaching your ear, which causes your eardrum to move in a little ways. And then that's followed by a rarefaction, which causes the eardrum to move away. And so the eardrum moves back and forth with the changes in air pressure as the sound wave reaches the ear. The greater the intensity of the sound wave, the greater the compression and rarefaction. So here we have a weak sound. Here we have a loud sound. Of course, it's much faster. You wouldn't be able to see this, but at least you can sort of visualize how the air molecules move back. They don't actually travel from the source to the listener, but they actually cause then the air molecules to move back and forth. When the sound wave travels through a solid, the solid itself, being much more rigid, is able to vibrate and can then transfer the sound signal from one end to the other end much faster.